I can use that time to introduce myself. My name is Colin. I am English, if you noticed, and don't ask me about Brexit because I don't have the answers. Also, this is my first time presenting, not just at Food Cafe, it's anywhere, so please be gentle. I'm a tender soul, so if you have any constructive feedback, I welcome it afterwards. Please give it to me, it's the only way I can get better. I've basically been a developer mainly in the web world for the last 11 years, I think. I graduated, and I've basically mainly been working in product and services companies, and doing kind of .NET backend, basically, web services and that sort of stuff. So what is Rust? Rust is a systems programming language, and it's a statically typed systems programming language. It's been around since 2006. It came out of Mozilla as part of a research there, and then it's been sponsored and it's been developed through several versions and some quite significant changes. And it makes some claims about being blazing fast, memory efficient, having ownership and memory model that reduces errors, and also being very supportive to you. And the same is said of the community around Rust. It's meant to be very friendly, quite open and open discussion, and although a lot of languages I'm sure can claim that. So I'm not sure, I haven't spent that much time in the community, so we'll find out a bit more. So just a quick show of hands, how many people are C or C++ developers here? Okay, quite a few. Any Golang? Golang? Any Rust developers? Oh, 2. Okay, great. So we've got a good mix. So from your perspective, it might seem strange that a C# developer in the web world is looking into a systems language like Rust, and you're kind of right. It is a bit weird. And in the words of Dave Grohl, I have a confession to make, and that is the last time I did C++, I was significantly younger, had significantly less grey hair, and significantly thinner as well. So we're talking a decade or so. So I've got a little bit of catching up to do on a lot of development. So if you have any interesting input from the C++ or Golang environment, please just fire it in, because it's great for me to hear from personal experiences for people working with it on a day-to-day basis. So again, why Rust? So I'd like to introduce one of my colleagues, Alexander. He's sitting next to me. And Alexander's been working with us for about a year. And he's one of those infuriatingly enthusiastic developers that comes in and seems to have a finger on the pulse. And Alexander loves Docker, and he loves Rust, and he loves Rust in containers. And he tells us about this quite often. So I did what most other good colleagues do, and I completely ignored him until the Stackoverflow results came out for 2019. In there, you can see Rust down there as a 3% sort of professional usage, which is quite low. But what was interesting was it had an 83.5% love rating. It was the most loved language, and there was that for the 4th year in a row, which is quite impressive. And also it had like a 10% kind of wanted rating as well, which was, it's a bit below Go and below Python, which is definitely a popular language at the moment, TypeScript and Kotlin as well, but it's still up there, which is pretty impressive. So unless they have some sort of crazy North Korea style indoctrination where Rust can predict the weather or other amazing feats, they seem pretty happy. And maybe there's something good here. So intrigued a little bit further, had a look around, and it's starting to crop up in places. These first two, the top two, are Microsoft, and they have next to Go, they also have Rust and Swift, so other sort of languages there. And also there was mentions of it in this Quantum project from Mozilla. Azure IoT Edge is using Rust. The Dropbox and Cloudflare are now using for their file systems, and Cloudflare are using it for running WASM, so they're using Rust to compile to WASM and doing that. NPM and Twitter also have been using it as well for various toolings. I think Twitter were using it for some of their performance tracking monitoring. They wanted it to be fast and lightweight, and so they had something there in their public repositories. But a lot of the times, the kind of use case I came across was more people looking to take older, maybe legacy C and C++ projects and try and make them more manageable and more reliable, less error prone. So again, not at all relevant to my day-to-day activities, but interesting nonetheless. Yeah. So again, why Rust? We also had, as well as the Stack Overflow results and people being slightly interested in Rust, we also had some potential use cases internally. So we have an Electron app, which people use to manage their BIM system and BIM files, and that does some various functions like searching and scanning file directories, and anything we could do to make that run faster is great. We also have a number of legacy plugins for CAD applications that integrate our platform into the BIM or the CAD applications, things like Revit, if people are familiar with them, and they are C++. As well as our flagship black box product, which is BIMscript, which allows people to script their objects and create parameterized objects very easily, which is something that has historically been quite difficult. And that team, there's another team in our company working on that in Budapest, I believe, who are all C++ developers and working with that on a day-to-day basis. So there was some kind of like potential for us to maybe leverage it in some way. And also, lastly, I just wanted to expand my horizons, and I felt a bit bad being encamped in C# and .NET Core and all that. So time to branch out and experiment. So I think my slides are in the wrong order there. So why are Rustaceans, as they're called, really happy? And it's probably not because of their spineless orange mascot. Not him, but Ferris, who is their crab. And yes, they have a small community there. We're selling plush products around this icon. But I started to find out why they were happy, and it's really easy to do because they've made pretty much everything public. They have great documentation, and it takes you through the whole process. And that's where I started. And if you're starting with Rust, really, you can't really get away from Cargo, which is their package management. There are obviously you can do Rust with just the Rust compiler, but for day-to-day stuff, they always recommend using Cargo, and that does a lot of the heavy lifting for you in terms of building, running projects, setting up projects, running tests, and it all links in with their crates.io site, which is essentially their npm or their NuGet for Rust. It doesn't look like a very impressive website, but it does the job. And it's here that with Cargo and with Rust, you can develop packages, publish them, share them, and bring in your dependencies. And it's also where you can yank your packages if you happen to have pushed a bad package. So you can, if you push something, it stays there because you might be dependencies on it, but you can stop people from taking on your package, but it will always live there, immortalized. So when you're setting up a project in Rust, there's two types of projects. There's a binary project and there's a lib project. The lib project is basically for sharing. It's basically your public code that you want to share with other people. And your binary is also kind of an executable project, basically, which you'll compile, you'll run, depending on your platform you're running or building to. That can also be shared if you're sharing tools or functionality. And to do that, basically, if I switch to the next thing, you get, when you do your Cargo and you set up your project, you'll get a basic project setup. Oh, sorry, it's on the wrong screen. There we go. Thank you. So you'll start off with the Cargo init, and you'll get a fire alarm. There we go. No problem. You'll get basically a basic template for your project, and it gives you a lot of possibilities to kind of to add little extra features to your project template. So just to take you through the initial kind of setup, you have your benchmark folder, and these are all understood by Cargo. So you can run your benchmarks, testing or performance testing. You can set up examples, which when you publish your crate will be published with it, so people can look at your best practices and use how to use your package or your crate, as it's called. Your source, which is where your code will actually live, and that's also known as the crate root, and the target folder, which is where it builds to. You can also have tests as well, and that's all understood. This is integration tests, and you can run these by just running cargo test. Also nice as well is you can run cargo doc open, and this is a nice feature of Cargo, and it will take your package and all its dependencies and it will build it into documentation for you. So out of the box you get this nice sort of way where you can look at specific functions, and if you've well commented your code, you can then get drilled down through your sort of API library and have a look at sort of definitions that you've created. And so it all helps, and it also bring in all the package dependencies as well. So it's a really nice little thing, what I particularly liked because it's something I find lacking. I mean, there's ways around it in C# and other products, but I thought it was nice that they give you that out of the box, and they encourage you actively to really write good documentation about your crates, and that's nice. So I think a good start. Documentation is usually the bit that I forget. I say or omit. And the basic organization is called the module system, or also called a module system, and it starts at the top level with a workspace, which is optional, and the workspace is for larger projects. So in most examples, and you see through the documentation, you don't see workspace in there. But what's nice about it is that you can set up multiple packages, and you set up what's called a TOML, cargo TOML file in the root, and you can manage your dependencies between multiple projects. And the TOML file and how it manages the packages and dependencies will stop you from using different dependencies in different projects. It will actively manage it for you, which is nice. So you don't end up with different package versions, which you can do. And it's quite strict about that, so it will just fail if you try and do that. The package is the project, and that can contain crates, which can be the binaries, but only one library per package. And that's organized into a tree of modules, which you can access via paths. So kind of like namespaces, if you're familiar with C#. It's very, very simple to get a hang of. And the module system is basically quite flexible, so you can organize things in the way you want to. That's quite a good start again. So the Rust language is a bit of an interesting one. So I came into it with no knowledge, and immediately it kind of felt familiar to me, which was interesting because I was expecting to go down the C++ way of, and what I remember from university of being completely like, what is this file and what's a pointer to a pointer? But it was pretty okay at the beginning. The basic sort of things like traits and types had some sort of relation to kind of inheritance or interfaces and objects in OO languages. Then there was a nice pattern matching addition, which is they use closures, which they openly say that they take from Ruby. I don't know Ruby at all, but so if anyone's programmed in that, they can maybe comment on that later. The pattern matching come from functional languages. And then they have smart pointers and borrowed references and a very C++ apparently familiar syntax. I don't know if anyone agrees with that from the C++ world. I've not been there for 10 years, so maybe it's changed significantly. But yeah, so it pinches, excuse the pun, from various different places to try to form something which feels like somewhere between a system language and a high-level language. It still has a lot of high-level abstractions, which we'll talk about later. So basic features. You get immutability by default, something they push very hard. They don't want people to mutate stuff unnecessarily, or if they do, they want to make sure that you know what you're doing. They have generics and traits, which I mentioned earlier. And traits are basically functionality that you can implement in different structs or against different structs, or as a bounded constraint to generic methods. We'll look at this in a bit. And you can apply that to your types. You have borrowed references, which many people were familiar with C++ will probably be familiar with, but not so common maybe in C#. Standard collections, tuples, vectors, and arrays. Arrays being on the stack and vectors being on the heap. And testing integrated in there. So the convention is to have tests close to your code if it's unit testing, and then integration tests in this test folder we saw on the higher level, which test the public interfaces. So we can have a look at some of those in a little bit more detail. If I go back here. I use Visual Studio Code. I don't know if anyone else is using any other IDEs for Rust. The people that are doing Rust, or is it VS Code? Genie. Okay, I've not seen that after. Is it good? Okay. Yeah. So VS Code I thought was a good choice because it has a lot of plugins written by the Rust community and stuff, so which helped me quite a lot. But perhaps for more seasoned developers of Rust, you can live dangerously, so to speak. So Rust basics, yeah. So as we discussed, you bring packages into the scope, basically by using them or importing them from the standard or from dependencies. You can define your structs. I've chosen a Harry Potter theme here, so I apologize if it insults anyone, but it was just interesting. I thought I'd try and make it less dull. And this is a building. You can then define your methods and other associated methods on a building. So you get something called where is it? Sorry. You get something called normal methods, and you can tell that by the self that is passed in, and that gives you access to the struct and their values. But you also have something called associated functions, which are kind of like shorthand constructors that help you kind of build up common patterns. So like if you want to build Hogwarts, potentially it's a game or something like that, and you want to build Hogwarts into the map, you can create little shortcuts which you can access by just kind of doing building, if I can type, building, semicolon, build Hogwarts. Oh, I'm not doing so well on the keyboard. Build Hogwarts, and then you can basically new up a new instance of that struct, which is quite nice. And then same can be applied everywhere, so it saves you a little bit of time. Other nice things as well as you can use objects as templates and auto-populate new objects from them. There's a little handy syntax. So if I was basing this, you could pass in an object, and then you can just sort of say, I want to populate these 3 fields, do a double dot, and then say, here's my template object that I want to build, and it will auto-populate that and auto-match names up. So again, nice little shorthand for kind of populating objects. Everything in Rust is snake case, I believe they call it. I've heard this called as Egyptian brackets. I think it's more common in the C++ world, but it's to kind of walk like an Egyptian. Very unfamiliar for me as a C# developer because it's always a camel and stuff. And also everything's lowercase and separated by commas. But this is a trait, and this is kind of like what Rust does to deal with sort of polymorphism in a sense. It doesn't have inheritance. You can't subtype a struct, but you can define traits which can be applied to different objects. And in that way, you can do some stuff with trait objects, what they're called, where you don't care about what object it is. You just want to run something on it. So in this case, defend. Define a defend cast protection spell, and then I define a implementation of that method, which is just going to print something. It's very simple in this example. Yeah, it feels to me. I don't know Go at all, so I can't comment on Go. But from from C#, it felt like interfaces, and that's immediately felt like intuitive and sort of familiar to me. But maybe as it goes, it feels you can add. Yeah, it probably is. I've heard one of the things that came up possible all the way through my kind of like investigation and research was that usually people were kind of talking about Go and Rust in a similar way, and although it seems like Go has more popularity in sort of in usage, it did have a lower satisfaction rating. So I can't comment on that, but maybe it's just because there's more people using it. I don't know, statistics. Um, and you can use those traits again, as I said, for trait bounds on methods, so you can define objects that you want to pass in to do some function on, and also you can use them in generics again as trait bounds, so you can pass in two objects and then cast your protection spell, and it could be a user in the game or a building in a game that's able to protect itself in some way. And again, sorry, I just ran through it basically. And then you can also have, sorry, I missed derived traits as well. So you can define your own traits, your custom traits which you can apply, and you can share for people consuming the package, but also inside the package. But you also have a lot of out-the-box derived traits right at the top here. You can derive debug and partial equality, and they come with default implementations. So if you want to compare your two types of buildings, as I do here, so I'm comparing Hogwarts and the Ministry of Magic. You can use this debug syntax, which will just print output a nice representation, like a printed of the object you want, and you can also. Oh, that's not what I wanted to click. You can also do equality comparisons, and it just goes through the fields, properties of your object by default and sequentially and compares them. So it's really nice, really quick. Just, I don't have to worry about implementing it every single time or creating my own custom. I can do if I want to, but I get something out the box, which is quite nice. I could just run this. If I can, did I type something somewhere? Can't go run. Example. So I've made some examples in this repository, and you can run them just with a flag, and then you can run each build and run the examples. For example, basics, and then you get your output basically from things. So there's the debug representation of the. If I can get there, sorry, trackpad. Where was it? Yeah, there's the debug implementation and some of the output from the things I've done in there. Basic for loops. Yeah, nothing revolutionary there. Most people should be able to pick up that fairly quickly, which is okay, unless you're completely new to programming. But yeah, so far nothing kind of like was like wow, everything was quite familiar. So a fairly solid base. Then things get a little bit more interesting, and this is where, for me personally, it was a little bit more challenging because I had to go back to the time when I have to worry about pointers and memory management, which I've not had to do. The luxury of the C# world to just let the garbage collector come and pick everything up. So Rust puts a lot of emphasis on its scoped-based memory management, or what it calls the ownership system, which encapsulates both scope management and lifetimes. It also has borrowed some functional stuff for enums, which is made quite powerful compared to my point of reference, which is C# enums, which is just basically type. They get rid of nullable references and bring in two types, generic types called option T and result TE, which we'll talk about in a bit. And they also have something called channels to handle thread-based and concurrent programming. They call it concurrent, but they say that they reference that as concurrent and parallel programming. Again, not something I've delved into that much, but it was interesting to look into it a little bit more. Good channels. They did actually reference the Go documentation when they talked about it was a quote, it was something like, don't share memory, share communication, or something. It's something that's pretty just off the top of my head, so I may forget it. So their scope management is something that's probably quite, I think, familiar with C++, something called the resource acquisition is initialization, or RAII, method of managing memory. And the compiler enforces this quite strictly. So it's there to cut out common errors, specifically with sort of dangling references and using things that accessing memory that might not have something in that you expect, to cut down security issues as well. With the error handling, which it uses option T in results, and which is based on the enums as well, it makes an extra point of saying that if you make a mistake in this, it will in any of this, if you happen to get past the compiler, things just panic and they fall over. So rather than actually try and read memory, it will just stop and die if you haven't handled it. So they try and make things a bit safer there. So we can have a look at that in a little bit more detail as well. So let's start with, where's my cursor? Scope-based management. And I apologize if this is too basic for some of you who have been working in it, but where am I? Source. Yes. So one difference from, apparently I gather, from C++ is how it manages ownership of values. So in this top example, we define a string on the heap, and we then allocate or copy the object into a new immutable variable, and then we print that out basically. If I do this line, I'll get an error, and that's because one subtle difference is that they don't do what they call shallow copy. They call it move, and this is there to enforce ownership, basically. Sorry. When you assign the description to the new description pointer, it automatically hands ownership over to this, and description dies. So if you try and access it beyond this point, the compiler will not let you. It won't let you run or build the project. And this is, again, to ensure that basically there can only be one thing referencing one bit of memory at a time. There are exceptions to this later on that I learned when they bring in smart pointers. But at the base level, the compiler is going to enforce this every time. If you're using borrowed references, then it doesn't hand over ownership. It's just a kind of a loan. So if you do a borrowed reference down here, and you're just doing something and returning a reference, nothing happens. The ownership is never handed over of the parameter. So you can then access it beyond. But if you actually do pass the object itself or the pointer, it takes ownership, and then in this scope of takes ownership, that will be destroyed when it leaves that method or function. So this is again building on the idea that it's trying to prevent common errors, double references to the things like that. So it's this was new to me, and I found it kind of interesting that you had to manage, going as a flashback, that you had to manage, and that these errors were possible in other languages, kind of thing. It's nice to have someone sort of checking that for you. Who frees memory? So I think everything has a drop capability, a drop trait on it, or a deref, trait on it, basically. So as soon as it goes out of scope, it will call a deref and drop it, basically, and it's just the scope that manages, so you can't control that. So it's somewhere between kind of garbage collection and somewhere between manual. So it's a little. Yeah. So the compiler also has something called uh, the borrow checker in there as well, which is an extra feature, which basically takes care of all the borrowed references. So this is the reference checker, and it does that basically by looking also again at scope. So in this case, we assign X, and then we pass the reference to X into R, which is defined in the outer scope, and then we try and access R afterwards. And the borrow checker will just stop this from happening. Basically, it will again flag you up and tell you that you're trying to use something that has been borrowed and dropped. Uh, I don't know. I can't answer that question. Uh, but yes, yes, they do have smart pointers where you can box things so you can store multiple types, and they also have, I think, one of these smart pointers. There's two types. I have to admit, this is like in the later stage of the book where it gets into the more advanced topics, and they have a thread safe smart pointer which does allows you to have multiple references to a single. Yeah, exactly. So it's a little extra information in a normal borrow reference, basically. And then they also have a normal one, which is not thread safe. And you can use these to get round some of the, or do some more complex stuff with memory management and multiple ownership. I didn't get so deep into that, so I can't really elaborate more on that. But it's all in the book about how you can kind of make some sacrifices between kind of runtime and also the compile and the actual binary size. And one of the things the borrow checker does with references as well is it forces you to kind of make some decisions in some cases by using a system called lifetime elision. It's been a long time. I've never heard of it before. I gather it's something in C++ as well. But in this situation, where we're passing, we have a city, really basic example, and we and we pass in three or two types of city into um, into the object, and we can return one or the other. We're trying to return the largest city, essentially. Um, the compiler doesn't know how to manage the resources there. It knows you have references to objects, but it can't guarantee. It doesn't know whether you're trying to use a resource that may have gone out of scope or access. So it forces you to make a decision on that using lifetime elision rules. And it brings in this concept of lifetime, which you saw in the previous slide, where these little X boxes, and it checks and it forces you to choose one of those lifetimes and bring it in to the method. So this is called a input lifetime, and then the return type has output lifetime, and the output lifetime has to match one of the input lifetimes. And by specifying this, the compiler can then enforce that you're not doing something naughty with memory. And then the compiler will stop you from. You have to basically decide this. In this case, we're deciding that these have to exist in the same lifetime because either one can be returned. But then depending on the scope you might have of the references or the variables you're using, you might have different ones. It's automatically out of the box designed to assign a new lifetime to each input, basically. But if it can't resolve it, then you have to specify it yourself. And this is all there to try and prevent you from doing bad things and to make the compiler as verbose and as strict as possible. And it really is from a complete sort of systems program noob, or very lapsed, I should say. I got so much feedback from the compiler doing stuff wrong. I can do cargo build, and then I think it is no, because I've got 2 modules in here. Which one's the default? Yeah, it's this one. Okay, so I can do cargo build, and I should get. Oh, it worked. Oh, but I didn't save the file down. I should get some nice feedback here. Yeah, so immediately I get an error. Blah blah blah. Yeah, and again, it's looking here and it's telling me it expects a lifetime definition. It's expecting me to have defined that because it can't do it. But the signature does not say whether it's borrowed from city or city 1. So again, it's asking for me to define that scope. Immediately, like for someone who's maybe not so experienced with this sort of thing, you know, it gives you a point of reference to go and find out more. Like, okay, what is a lifetime? You know, what have I done wrong? That's good, which I liked particularly, and made me feel a little bit more kind of less afraid of making mistakes as well, because I was always terrified of doing wrong stuff with memory and C++ as a student. Now I can pretty much confidently say that someone's got my back here, and they will give you all sorts of feedback as well. Some of it's just like warnings, which cargo can actually run and fix automatically, which is quite nice. You can just write cargo fix and it goes away and corrects all your non-serious warnings and stuff like that. How am I doing for time as well? Just keep track of it. Yeah. So there's that, which is the scopes and lifetimes. So the ownership is the real key point for Rust. They also have this enum result type, or enum, which is quite powerful, more powerful than the C#, C# enums, and we can look at those as well. And they use the enums as the basis of their return types for functions for this option T, and input as well, option T and results. Going back, enums. Where are we? Examples. Blah, 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 blah. I should be using Control P. That would be faster. Enums here. So you can define enums. I'm showing my age here because this is a matrix reference. So you can define enums, and the enums can also take in different types of values. So you can have you can define like a response, an implementation to your enum, and you can do checks based on the enum value. You can pass in parameters into those enums and execute them. So in this example, and then you can also do pattern matching as well, which is one of the really good features of Rust, really powerful features, where you can just match yourself and do pattern matching and pass values in and do different actions based on the selected thing. And also because of that, you can also store these in vectors because it's the same type, and then you can get some like interesting behaviors there because you can execute the same property and get different outputs and have more different same type of object but different functionality operating on it. So in this case, you know, I can create a new enum. I can pass in the different variables, and I can call this implementation response on it each time, and get a match and then get some output. And they use the fact that you can have different values passed into enums as the basis of option T and the result TE, and they use these as a way of avoiding. Well, they don't have null references, and to help kind of make it more friendly and cut out more errors, they return. They encourage you to return result types in option T from functions, and what that does is means that you can kind of have. I think it's defined as option T like this, and then it'll either return you some value of t, or none, which is nothing. And basically what that means, if you get failure, you can return none, and the compiler can see that, check that you've handled that case, none. And then if you haven't handled maybe the circumstance, like you're doing a call across to some WebSocket and it fails, you don't just get null back, or you won't ever get a null reference. You'll get none, and you can check it and you can handle it nicely. And the same with result te. Essentially, it's the same as this. You get an OK back with the value that you expect, or you get an error type, basically. So you can then handle those errors, and you have all the information about what failed, and you can do pattern matching on the errors, so you can handle the different error cases, and basically gracefully kind of handle this, cutting out any possibility of needing to panic if you can avoid it, or panic being, or throw an exception, or have a null reference exception. So that's one of the ways they kind of try and avoid errors in the application and try and make it nicer. So you can see this in action. Yeah, so you can define things, you can unwrap them to get the value out, and then get default values if there's no value. So that, in this case, if you try and unwrap a failed thing, you'll get a panic if you don't check it before, or you can just do some simple pattern matching. If it's okay, return okay, or do some other function, or print it out. And you can also pass the value from your returned option or option and get it out, multiply it, and return new options. So you can basically layer up all the nice features, that you can protect your application from doing anything unexpected, and the compiler can check that you are not missing these cases. Pattern matching, also nice feature. So they have the concept of closures, or kind of reminded me of delegates, which they said was from Rust. And closures allow you to kind of define something and call it later. So if you and you can pass in parameters to that, and they can also take in variables from the main thread as well. And pattern matching has a host of kind of helpful functions as well, which you can do really quick things. You can iterate over a vector. You can combine it very simply by zipping them together, and then you can map those to. You can then do functions on those two values, so you get a tuple back, and then you can take A and B, sandwich them together into one value, filter out anything you don't like, very simple again, all using the closures. In this case, filtering out jazz, anything containing jazz, experimental jazz specifically, and then you collect and you get back your vector. And this reminded me very much of LINQ and C#, and it's kind of ease of use. And I thought this was super powerful, and I'm pretty sure I've only touched the surface of what you can do with this. Yeah, I think they talk about they thought there's some really nice stuff in other languages. We'll just take it and use it ourselves. So in that way, again, it's taken some of the nice features from everything from other languages as well. What else do we get to? Yeah, panic traits we talked about. Again, traits we talked about. You defining behaviors on different types of objects. The compiler can enforce that as well, so it can ensure that that the objects you're using implement the traits you have, and it will find them. So if you try and pass a string that doesn't implement a certain trait into a collection that defines the defend or some sort of copy trait, it will validate that for you and stop you from making that mistake. We talked about panic already. Interesting behavior as well with integer overflows as well. So if you try and go over if you have a type like a unsigned integer or 8 or something, and you try and go to a value that's not can't be stored in an I8, it just does a 2's complement folding over, so it just keeps running. So it won't error, it won't cause an error. It will just keep running a bit weirdly. So really, the compiler, I liken it to kind of a angry Gordon Ramsay shouting at you of all the things you've done wrong, which for me was quite a lot. So it was good. I enjoyed it, and it doesn't just shout at you; it gives you helpful pointers as well, and that's a big difference for me. It's not just you failed; it's you failed. You might want to try this, or have you done this? This one's broken. So overall, I really enjoyed that experience. Performance also is one of their kind of key points that they talk about, and the compiler is static, so it tries to for generics, it will basically generate a concrete implementation for each type that uses the generic. So it'll basically generate code for it. The pattern matching and the filtering and the things we've seen with closures, they basically said it's a high-level abstraction and it's a zero-cost abstraction. So if you were to handcraft the map function or the filter or the zip, it would basically run the same as the closure version, the abstraction. So they've taken that into consideration. They did say that the wording around it was that it should be pretty much the same. So there might be some variations there. In the example they gave, it actually their abstractions ran faster than the custom implementations, but they also put a big caveat on that, saying that there's a lot of things that we haven't considered in here. Loops and compiler optimizes the code, and you can actually specify different levels in the TOML file, which is a pretty important file in the project. So the TOML file exists at the root, has all your project information, and you can specify these optimization levels. So in release mode, you want the higher, you're sacrificing compile time, but for a higher and smaller package size. Dev time, we want nice and fast, but we don't care how big it is. Yeah, also I should mention that this is where you keep your dependencies. You can define dependencies from GitHub. The default one is crates.io, but you can also specify different places. And if you have your workspace where you have multiple packages, you can then do, or subcrates as well. You can also do basically relative paths to your crates and dependencies. I don't know, but I guess you probably could. I don't think you. Yeah. So I imagine it's possible. One of the nice things as well with the dependencies is when you're building your crates and your packages, you can have feature flags as well. So you can take a dependency, but you can also just take what you need out of that package. So you can define sub properties to really kind of manage how much you're taking into your code base. And you can define dev dependencies as well. So testing frameworks, things like that, you maybe want to only in that situation. And you can also, it's here that you define the example. So when I created the example code, you can create these little tags here and you point to your file, and that's what allows the cargo to recognize that you can build them and you can run them as well. And it's the same for there's various other kind of flags and customizations you can do in here, and there's whole documentation on that specifically for cargo. Yeah, you can. You can reference branches, hashes, and commits and stuff. So you can specify it quite sort of to fine tune as well. So if you want to branch off it and reference that, you can. So that's quite cool. So yeah, so there's a whole host of information about cargo and crates, and you can go down through all the different flags and all the different things as well. You can even do like fine version management as well, so you can it's not quite semver, but you can define using up to versions. So when you run cargo update, it'll update the versions of your packages and stuff like that to the versions the maximum version you want, to sort of avoid breaking changes, and that can be done down to each sem version. So again, nice sort of features. Yeah. You can also do trait objects we talked about, which is that's the only time, or one of the only times, you take a penalty, and that's when you can box some object that defines a trait. And this is something that was a bit over my head, but it's smart pointers again, and allows you to kind of pass in things where you don't have a known size at compile time. Basically, the box basically gives you a pointer, a slightly more fat pointer, and that has a fixed size, so you can then proceed and do some more things. But then you get dynamic dispatch because it has to resolve. It doesn't know what it's running on traits, so then it has to do a bit more in the runtime. So you'll get a slightly larger runtime from that. It also talks about, Rust also puts emphasis on concurrent parallel processing. Its main sort of argument for using threads again and it being safer in Rust is again relating to this lifetime and scopes. It'll validate that you're not using variables or sharing stuff in an invalid way, and it uses the one-to-one way of doing threading, which is not green threads, but you can introduce packages that give you a different type of threading if you want to, at the cost of a larger runtime, basically. But their decision making was that they wanted to keep the packages as small as possible. Yeah, again, the ownership rules help to prevent race conditions, and they have this feature called channels, which allows you to do wrong one. Allows you to do simple kind of threading. Target threading. Not targets. Where are we? Sorry again. Examples. Concurrency. So yeah, you can do sort of. You just basically define again a simple sort of threading example. You just spawn a thread and you run it, and then you can either you can wait. If you don't do this join, then it won't wait, and it will you can exit a little bit, or it will cause a problem. So the thread will run, the main thread will continue, and then you basically wait for this thread to finish doing what it's doing. And then, so that's a very basic example of the threading which they provide. And then they give you the idea of something called channels. So you get this, is it multiple provider, single consumer? It's a good question, but I guess it's probably something to do with ensuring that it's tied. Yeah. I don't know. I'd have to go and have to look at the kind of arguments for that. Maybe there's some discussion in Reddit or something. But that you can create multiple senders. So in this case, we're basically just taking an array, and then we're creating a thread, creating a random number, picking Newt monster. Spelling mistake. No spell checker apparently. Why is it? Newt monster or human, choosing a random one and sending it into a stream essentially. And as soon as that you send it, the variable that you send goes out of scope. You lose ownership over it. And then you can define a consumer, which just waits for this to complete, and will process it as it comes in. As soon as the senders actually stop doing what they're thinking, it will also dispose of the receiver as well. And you can clone and have multiple receivers, multiple senders, and they can all be operating at the same time. and you can just, if I uncomment that, you can clone the. This extracts the sender and the receiver from into a tuple, and you can access those separately. You can clone it, and then you can do the two functions. So each one of these will do something different. I can quickly. How are we doing for time? Not too much longer. How hungry are people? I'll continue just for the moment. You can shoot me later. So yeah, using channels. I can do currency. Spelling's not my strong point. We can. Yeah, we can run. And it didn't run as I expected. Oh, the presentation bug has struck. Where is it? 2 threads, tx1, tx2, 2 receivers. Did I forget to save and build? Cargo, build. Example. Finished running. Try again. Oh yeah, there we go. Now it's working. So the first thread should turn me into human. The other one should turn me into newt. But I got better again. If anyone gets that references, I'll give you a beer later. So yeah, and then it also Rust provides you the sort of things that I think are quite common, mutex, which allows you to kind of do shared memory access, and it has various other things around it. Reference counter pointers, this thing called arc, which is atomically referenced counter, which basically ensures that you're not doing unthread safe referencing at a slight performance degradation, but there's other ones as well which you can do. So basically this is kind of what they offer out of the box, and it always tries to steer you towards doing safe and not making errors, and that's quite cool. One of the other use cases we had for Rust specifically was WebAssembly. And there's this thing called WASM pack, or there's reference there, WASM pack, and WASM bindgen package that you can import into your project. And this gives a slightly different use case from a systems programming language. So it's leveraging the fact that Rust is safe and fast and small to compile something that will run in a browser with native speeds, basically. And you can install this and add it into your kind of Rust project very easily, and then you start using this WASM build command to kind of build your Rust project into its target. It's like a target triple, and it's like unknown, and it generates this WASM thing. And the WASM package that you can and target gives you testing for the WASM as well, the WASM file. And the fact that there's no garbage collection means that package that you generate in WASM can be very, very small. But there are some limitations to using to WebAssembly with Rust. The WASM bindgen package, which is really powerful, is really helpful. It has limited types. The WebAssembly has a linear memory, which means that when you're thinking about running your Rust, you have to think about mapping things in a different way into memory and how you would use that. And the fact that it's only a subset of types that are bindable between JS and Rust means you can't use all of Rust's sort of features with the JavaScript. Things like vectors, arrays aren't parsable between JavaScript and WASM, WebAssembly, unless you go and look at this solution called Serde, which allows you to do this, but by serializing things across the boundary, which is a performance hit if you're using WASM. And one of the main reasons you use WASM and Rust to do it is you want it to be fast. So it's a bit of a limitation, but if you have something, there seems to be a load of ways around it. But I started going down the WASM path and starting to write it, and it got complex, and my front-end skills are lacking as well. So I ended up basically sort of summarizing it that if you're not really good at JavaScript and you don't have a really good use case for WASM, then it might be quite hard to kind of really leverage its strong points. But there are some definite cases where you can get some blisteringly fast functionality from it. The example they have in the Rust book is a game of life, but that's all just using integers to generate sort of patterns and redrawing stuff into JavaScript into the browser basically. Yeah. So quick summary, because I know we're keen for pizza. I think from what I saw, it felt like Rust was a good language for people maybe working backwards. People maybe who maybe want to learn a lower level language but don't necessarily want to leave the comfort zone of having to manage memory themselves or going down to manually allocating stuff. It felt like if I wrote Rust as well, then it would probably be easier for someone else to pick up down the road. So maybe if you have old C++ libraries or C libraries that you want to convert, maybe that would lead to lower maintenance over time. And if you have like a need for really high performance functionality from WASM, it might be good to use Rust because then you can really leverage Rust's strengths and generate some really fast WASM files that could save you a lot of time. But you might need to think about why you're using it in your use case, if it's a good fit, and whether you're prepared to sort of redo your code in a way that would work well with how WASM works with memory and how you would have to use that from your JS. I think that was it. The repository is public in GitHub if anyone wants it, and the slides are public as well. But that's all from me.